So sine of 300 degrees, again, I'm going to do all these the same way. I'm going to find the reference angle. If you need to, you can draw a picture. 300 would put you here, which is 60 degrees short of 360, right? Or hopefully we're trying to, by now we can see that the sine, or that the reference angle is 60 degrees, right? We should be able to get to those quickly. We have little formulas for that, but I try to stay away from those. Sine is 60. We all know is it a half or root 3 over 2? Root 3 over 2. So that means the sine of 300 is also root 3 over 2, but maybe I make it negative. Do I make it negative?
Yes.
Yes, because the sine in quadrant 4 is negative. Okay? Tangent of negative 60, that's just an angle down here at negative 60 degrees. So I can say the reference angle is 60 degrees. Right? But I'm in quadrant 4. That's the important part. You know you're in quadrant 4. So the tangent of 60 degrees we have memorized as root 3, just root 3, not root 3 over 3. And then do I make that negative?
Yes.
Yes, because it's in quadrant 4. Okay? Cosine 120, what is the reference angle? 60 degrees again. So 120 would be here. Means you're 60 degrees short of 180. Right? Or 180 minus 120 gives you 60 degrees. So I want to look at the cosine of 60, which I know is a half, which makes the cosine of 120 also 1/2, but I have to make it negative because it's in quadrant 2. Cosine is negative there because x is negative there. Sine of 30. Oh, that was an easy one. That was in quadrant 1. So we already know the sine of 30 is 1/2. Same as the cosine of 60. And that has to be positive because it's in quadrant 1. Tangent at 225. Reference angle should be pretty clear. Because it ends in a 5, the reference angle has to be 45. So it's a 45 degree. If I drew the picture, 225 would be 180 degrees, and then 45 more. So that puts me in quadrant 3 with a reference angle of 45. Tangent of 45, 1, making the tangent of 225, 1. And then I decide if it's negative or not. It's not negative because it's in tangent 3. And we know that in tangent 3, quadrant 3, sorry. We know in quadrant 3 that the tangent is positive. All students take calculus, that's who's positive in which quadrant. Okay? So it's 1. The tangent of 225 is 1. Sine of 3 pi over 2, that's number 11. We can do that one now. I always do the unit circle approach for these special quadrantal angles that land right in between two quadrants. So 3 pi over 2 is in between quadrant 3 and 4. And the point on the unit circle is 0, negative 1, making the sine of 3 pi over 2 negative 1 because it's the y value. Same thing on the unit circle. So I use the unit circle approach for those guys. Okay, let's keep moving. Now we can talk about our radian angles. 3 pi over 4 has a reference angle of what? Pi over 4, right? So I'm interested in that, which is 1. And so that also is 1. And 3 pi over 4 is in quadrant 2, which means it has to be negative. Okay, good. 7 pi over 6. What quadrant is that in? 2 or 3? 3. 7 pi over 6 goes, what is that as a radian angle measurement with a denominator of 6? It's pi, but what is it with a denominator of 6? 6 pi over 6, right? So I have to go another pi over 6. It's just adding fractions. I got to go one more pi over 6 to get there. That's 7 pi over 6. 6 pi over 6 plus 1 pi over 6 is 7 pi over 6. These are in quadrant 3. The reference angle, of course, would be pi over 6. And we all know that the sine of pi over 6 is equal to 1/2. Right? So that means this is also 1/2, but because it's in quadrant 3, it's negative. So that would have been a mistake. If you thought that was in 2, you would have had a positive 1/2 there. Right? Sometimes you get lucky. If you thought that was in quadrant, 4, and you knew the sine of pi over 6, you still get the right answer, right? Because the reference angle will be pi over 6, 1/2, and then even if you're in this quadrant, you get lucky and you get the same answer, right? Because sine's negative here and here. Okay, secant of 4 pi over 3. So for this one, I got to find the cosine of 4 pi over 3. Did we do that one up here? Cosine 4 pi over 3. 4 pi over 3 is pi plus pi over 3, or 180 plus 60. So it's 240 degrees. So not real. Okay, so if we're doing this one from scratch, we would have to find cosine of the reference angle, which is pi over 3. And what is that? That's a half, making the cosine of 4 pi over 3 also a half, but maybe negative. Quadrant 3. Quadrant 3, so that would be negative, right? Without a picture, the reference angle is pi over 3. Cosine of pi over 3 is a half. I put it in its proper quadrant. That's pi plus pi over 3, so that's quadrant 3, making the cosine negative there, making the secant negative 2 over 1 or negative 2. Okay. Cosine 5 pi over 6. Without thinking, I can say cosine pi over 6, which is root 3 over 2. Oh, we haven't seen that one yet today. Root 3 over 2, or at least on these examples. Root 3 over 2 is the cosine of pi over 6. So the cosine of 5 pi over 6 is also root 3 over 2. And then I decide if I make it negative. What quadrant is 5 pi over 6 in? Quadrant 2. Correct. That's pi over 6 short of pi. Right? You didn't quite make it to 6 pi over 6. 5 pi over 6 goes and stops short of pi. Right? Pi, or 6 pi over 6 is pi, so it didn't quite make it. It's in quadrant 2. All right, 2 more to go. Cotangent of 7 pi over 4, I would look at the tangent of 7 pi over 4, which means I would look at the tangent of pi over 4, the reference angle. That's an easy one. Tangent of pi over 4 is 1. Making the tangent of 7 pi over 4 also 1, but maybe negative. What quadrant is 7 pi over 4 at? Fourth quadrant, right? It's pi over 4 short of 8 pi over 4. Or pi over 4 short of 2 pi. Quadrant 4, which means tangent is negative there. And then the cotangent would be the reciprocal of that. The reciprocal of negative 1 is negative 1. And then finally, the tangent of 8 pi. The only angle I gave you that was greater than 2 pi. So how do we get, how do we find the measurement there? Well, you can understand that 8 pi puts you the same place as 0. Same place as 2 pi. Same place as 4 pi, right? If I did some revolutions, that's 2 pi. That is 4 pi. That is 6 pi. And that is 8 pi. Either way, you're in the same place. Well, you do subtraction. 8 pi minus 2 pi minus 2 pi minus 2 pi. Either way, you're right here on the unit circle. When I say right here, I mean 1, 0. And I know the tangent of that has to be y over x. Y over x, which is also the sine of the angle divided by the cosine of the angle. Same thing on the unit circle. And that means it is 0 over 1 or 0.